Hello, physics class. It's Mr. Ng, and quite a few of you had the same questions from our momentum packet this week, so I wanted to make you a short video to kind of walk you through it in case you needed the help. Let's go through numbers 10, 11, and 12 from the middle of your packet. Number 10 is asking, what is the momentum of the golf ball with this mass and this velocity? Well, that's pretty easy. We all know that momentum is P, and momentum is the mass times the velocity. So that means P is equal to not 62 grams. This is, we got to change this to kilograms. So you just have to do 62 divided by 1,000. So this is 0.062 kilograms, right? Again, we don't want grams, we want kilograms. So we just convert it into 0.062. We just divided it by 1,000. And then we multiply this by our velocity, which is 73 meters a second. So if you multiply those two across, you get a momentum of 4.5 kilogram meters a second. Done. And then it gets a little bit goofy here with 11 and 12, mainly because a lot of us forgot our other special equation. Aside from knowing P is equal to M times V, there's another fancy equation where we say J, the impulse, right, the change in momentum, is equal to the force times time. This was our second big equation for this unit. Impulse, the change in momentum, is force times time. So here, we went from 0 momentum in the beginning with this golf ball to a momentum of 4.5. So in the problem above, the impact between the ball and the club lasted 4.002 seconds. This is a time. What force acted on the ball? What force acted on the club? Okay, so let's think this through. And let's have a little key here. We need to have our impulse, right, which is the change in P, and we'll need to have our force and our time. Our change in P, this is the difference, the change in the momentum, and we went from 0 to this. So if the change in P is the final momentum minus the initial momentum, our final momentum is 4.5 kilogram meters a second. Our initial momentum is basically 0. So obviously, our J, our impulse, is 4.5 kilogram meters a second. That's pretty good. And we do have a time. Our time is 0.002 seconds, and we don't know our force. So if we were to take this equation, let's rearrange it a little bit so we find the force. Our force is equal to our impulse divided by the time. See that? So this is our impulse, this is our time. So that means our force is equal to 4.5 kilogram meters a second divided by the time of 0.002 seconds. I'll punch that in real quick. 4.5 divided by 0.002, and I got a really large force. Our force is, here, let me erase this. Get out of here, question mark. Our force is 2,250 newtons. Done. And if you remember Newton's third law, this force is shared. This force is on both the ball and the club. So both of these will have the same force. And if you want, it doesn't matter which one's positive or which one's negative. Just make one of these positive, 2250, and the other one negative 2250. That's a little bit arbitrary. We don't know like at what direction they hit it, right? To the right is positive, to the left is negative. Done. That's a golf club, by the way. Lastly, for how long must a tow truck pull with a force? So we already have a force on a stalled a 1200 kilogram car to give it this momentum. So here we have to kind of mix both of these together, right? Where it wants us to first find the change of momentum, which is going to be equal to J, and then we'll need to find our F and our T. So let's first find our change of momentum. Look, we have a mass, right? We have a velocity. So we can find our momentum, right? Our momentum here is 1200 times 2, right? Mass times velocity, right? This is going to be our final momentum, and then we just minus 0 because it started at an initial momentum of 0. So what's the J? What's the impulse? What's the change of momentum here? 1200 times 2. So we have an impulse of 2,400 kilogram meters a second. See what I did there? I just found the change in momentum, and we assumed that the car was still had a 0 momentum to this positive momentum of 2,400 kilogram meters a second. So that's our J, that's our impulse. We don't know the force. Oh, we do know the force. It's 550 newtons, and we don't know the time. So again, go back to the old trusty equation. J is equal to F times T. This time we want to solve for T. So we're going to divide both sides by F. My T is equal to the impulse divided by the force. And I have an impulse. It's right here. I have a force. It's right here. So let's do that. My time is equal to the impulse, 2400 kilogram meters a second. I'm going to divide that by my force of 550 newtons, which I got right here, which I got from here. So my time is 4.4 seconds. Done. Okay, big picture. Basically, the ones that a lot of you guys were goofing on relied on an equation that we forgot. Basically, this impulse equation. And this impulse, it's some of us are having a difficulty finding it because maybe you just didn't realize that impulse is basically the change in momentum, right? So if you have masses and velocities, you can find that impulse. Hey, thank you very much for watching.